All right, Chapter 8 is about hypothesis tests. And before we talk about hypothesis tests, I need to talk about something else that's important called the central limit theorem. And this is one of the most important ideas in all of statistics. And it's why the normal distribution is called the normal distribution. What I want you to imagine is, imagine you have some kind of distribution. And let's imagine that your first distribution is a uniform distribution. So every single person has the same value or the same chance of being selected, and they all have the same value. Next, I want you to imagine a second distribution called a binomial distribution. So you know that that's the kind of looks like a Mayan temple. Okay, that's a distribution. Now let's imagine some crazy distribution that looks like this. Kind of just making this up as I go. Let's imagine that you have a very interesting bimodal kind of distribution. And then finally, imagine we've got some exponential distribution. So some distribution that looks like this. And these could be measuring anything. They could be measuring, anything. Here's the idea. I want you to imagine, first off, let this represent the entire population. Okay, let this box represent the entire population. What that means is we would have a population average right in the middle. Okay, and for the uniform distribution. For the binomial, the population average is right in the middle. For this distribution, it's kind of symmetrical. Let's imagine I make this hill right here a little bigger. So maybe the average of all of these values is right here. So that way it's not symmetrical. And you can see that this one's obviously not symmetrical, so the average of value is maybe right here. Actually, it looks like there's more of the lower ones. No, let's say that the average is here because there's more people over here, so the average is right here. So here are the 4 population averages from these 4 different populations. Okay, here's the idea. What happens if I take a random sample from this group? Imagine I pick a bunch of random people in this population. I might get this person, this person, this person, this person, this person, and this person maybe. All right. If I average those 6 people, I will get an X bar, an average of that sample. And maybe the average is about right here because I had this one outlier way up here, right? Now imagine that I take another sample. I'll pick this person, this person, this person, this person, this person, this person. I take the average of everybody. I might get an X bar over here maybe. Then let's imagine I do another one and I pick this person, 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 and maybe I get an average right here. Do you see that every time I pull an average, they're kind of close to the middle, which would be good. If I'm randomly choosing people, I should get an average that's kind of close to the middle. But we all know that if it's random, then there's a small chance I pick this group. This person, this person, this person, this person, this person, this person. There's a really small chance that I pick only people that are below average, and so I get an X bar way over here. That's way far away from the average of the population. So, are you with me? I took 4 different surveys and got 4 different X bars. It turns out that if you do this lots and lots of times, and if your samples have more and more people, these samples themselves will fall onto a normal distribution. It's not, most of them will be close to whatever the true answer is. Most of them will be close, or hopefully really close, to whatever the true answer is. However, it is possible to get one that's way on the edge, that's an outlier. I'm not saying it's impossible. If it was impossible, there'd be no line right here. But it's just really unlikely. It's much less likely to get this sample than these ones. That's the idea. The central limit theorem says that as you take sample averages from a population, those sample averages will fall on a normal distribution, with most of your sample averages being close to the true average, and every now and then you might get an outlier on one side or the other just by chance. That's nice, and it's kind of easy to see that that's true with a uniform distribution, but here's what's amazing about the central limit theorem. The thing that's amazing about it is it doesn't matter what your underlying distribution looks like, your averages will always fall on a normal distribution. And that's just incredible because it means that as long as you have a big enough sample size, it doesn't matter what the underlying population is and what the underlying structure is, we will still be able to make predictions about whether or not a claim is true or not, even if we know nothing about the population, which is just incredible, and it's why this is called the normal distribution. So again, imagine I've got my normal distribution around the binomial. If I were to take a bunch of x bars from this, they would still be normal. Even this one will pull a normal distribution. I'm a little bit more likely to get some from this pile and a couple from this pile and maybe one out of here. And that'll give me an x bar or an x bar or an x bar. Or maybe I pick a lot of people from this pile so I get an outlier x bar over here. Still doesn't matter. They're all going to fall on this normal distribution next to the mu. Or look at this one with the exponential. The average is right here. So if I pick a couple values from here, I might get a couple from over here. Again, it forms the averages form a normal distribution. Maybe once in a while you get one on the edge, but the averages form a normal distribution around the mean of the population. And so that's the idea. That's the idea of the central limit theorem. If you search for YouTube or on Google or Bing or DuckDuckGo, if you search for central limit theorem example or central limit theorem explanation, you'll probably get some really neat graphics that further demonstrates this. But hopefully this little video intro is a good enough introduction of what the central limit theorem says and what it means. The idea is doesn't matter what the underlying distribution looks like, as long as you take enough samples and you have enough people in each one of your samples, the samples themselves form a normal distribution. And that peaks around the mean of the population with tails going off in either direction. Okay, now that we've talked about the central limit theorem, in the next video we're going to look at what a hypothesis test is, and then finally we'll actually start chapter 8. So I'll see you in the next video.